let's get going with the lesson. So in the last lesson, what we were talking about was something called the sine rule. And today in class, we're going to move on to something called the area rule. But before we do that, I just want to remind us about how the sine rule worked and one little situation which can arise called the ambiguous case. So what the sine rule normally said was it looked something like this. And so in practice, what we had was we would have something like the sine of 30 over like a number 3 equals the sine of another angle, let's say B, over 4. If you remember that from the last lesson, give me a thumbs up. If you have never seen that before or have forgotten it, give me a thumbs down in the chat. I just want a quick feel for the people who've seen stuff like that and who haven't, etc., etc. Now, if you're new, you may find this first a little bit confusing because it refers to the last lesson, but we're going to start with the area rule soon, and that's going to be completely new work for everyone. Okay. So just before I cover this special case called the ambiguous case, I want to ask you if you remember something called the reduction formula. And the reduction formula says that the sine of 30 is equal to the sine of 150. Or another way of saying it is that the sine of 100, sometimes people would say something like the sine of x is equal to the sine of 180 minus x. Give me a thumbs up if you've seen that before. Now, the reason I'm bringing this up at the very beginning is that this is an example of the reduction formula. And one of the things that can happen is that there can be two different angles, yet the sine of that angle is still equal to the same thing. So one of the things we have to watch out for when we use the sine rule is sometimes it's possible that there are two answers to a question using the sine rule. And I didn't cover this in the last lesson because I thought that it would be a little bit too much too soon. But because the sine of 150 or the is possible sometimes to get two answers when using the sine rule. Now, just to prove that this is true, I'm going to go to my calculator and go, what is the sine of 30 equal to? And if I do that, the sine of 30 is a half. And if I then type the sine of 150, okay, I also get a half. So the first thing I want to make sure, and again, if you agree with this, if you understand that the sine of 30 is the same as the sine of 150, based on what you saw on the calculator, give me a thumbs up. And if you're feeling a bit lost about why sine of 30 equals sine of 150, give me a thumbs down. Okay, now, bearing that in mind, even if you're feeling a bit unsure, let us go to a question that is a lot like what we were doing in the last lesson. I actually want someone to help me. Okay, so, and especially for our new students, you're just going to pause for a second and let some of the students who were here last time help me. I want to try and find what the size of the angle is. Who would like to help me think through the process of solving for this missing angle x using the sine rule? You just pop your hand up if you're willing to share your thinking and just talk me through how would you set up this question. Can we unmute Sine? Can you hear me?
Yeah, I can hear you. Can you hear me?
Loud and clear. Go ahead. What would you start by doing to find the value of x here, the angle x?
so for the angle x, wait, let me just get my notes. Let me just. Okay, so we're going to say sine x.
Okay. And then?
Sine x over 19.
Okay.
Is equals to sine b.
Sine of b, or b is 28, eh? So we'll go 28
Sine
over what?
over 14.
Perfect. Absolutely perfect. So you have helped us along the way. So step one, and especially for our new students, what the sine will say is the sine of an angle divided by the side opposite it is equal to the sine of the other angle divided by the side opposite that. And that's what we did in the last lesson. Can you help me with the next step?
Okay, so we're going to say 14. So 14 times sine x.
Well, aren't we going to move this 19 to the other side?
Yeah, I was going to start with the 14 and then the 19.
Oh, okay.
Yeah.
Cool.
So it's 14 times sine x.
Okay. So wouldn't you, if you go, would you agree with this? So if you see the 19 in yellow, would you agree with that?
Yes, sir.
Perfect. Thank you so much, Danele. Okay, now I want to ask, can you guys try and work out what the value of x is now using this equation that we've got here? We've said the sine of x is 19 times the sine of 28 over 14. Now, what do we get for a value for x? And this is where we're going to have to use the inverse sine function. So, in fact, we can even do the values first, so we can go. So we'll go 19 times 8 over 14. So really what you're trying to do is you're trying to solve this whole long thing. So what do we get for x? Now I see Keisha and Chuma and Ndudu and Caesar are saying that the angle that I found is 39.58 degrees. Now, you're not wrong. You are correct in what you've done. But if you look at the angle x, does the answer of 39.58 make sense? If you look at the visual, who would like to share their thinking about how I found that value for x? Does it make sense or does it not make sense if we look at the size of that angle? Keisha, let's go to you.
Can I answer that? So it doesn't make sense because angle B and angle C is supposed to be equal.
Well, I don't think they're meant to be equal, but look at how big this angle is. Does that angle look bigger than 90 or smaller than 90 to you?
It looks bigger than 90.
Okay, so would you agree the problem is 39.58 is too small to be that angle over there?
Yes, sir.
Perfect. Now, if you go back to the beginning of the lesson, part of this problem is that there are two possible answers for the value of x that can make this true. So how do you think we are going to find the true value of x for this triangle? What do you think I'm going to have to do? Who has an idea? Who has an idea for me? Orokanisa, let's go to you. I'm going to unmute you, Orokanisa. What do you think I should do based on the beginning of the lesson?
Hi, sir.
Hello.
what I think we're gonna do is we're gonna try to solve the triangle using sum of angles in the triangle.
You could do that, but all you need, well, the problem you have is you don't have this angle down here. So all that you need to do in this scenario is to figure out what this angle X is here, is you go 180 minus the 39.58. So this situation that I've given you here is called the ambiguous case. And the ambiguous case is when there are two possible answers to a sine rule question. And there are only two possible answers. It's either going to be the angle that you find, or the other option is just 180 minus the angle that you find. And the reason this happens, the reason it's possible to happen, showed you at the beginning of the lesson, that there are two answers to the question with the sine rule. So given that I've shown you that, what is my final answer going to be for X? And then Annie, I'll answer your question now. How did I get 39.58? I will show you that now. So Annie's asked, before I get to this, how did I find 39.58? And I'm going to go and show you now. So this should be 140.42. Okay, so Annie's asked, how did I get my X value like this? What I did is I'm just going to go shift sine, and then what I'm going to do is this value over here, I'm going to put that inside here. So I'm going to go 19 times the sine of 28 over 14. And so all I'm really doing is I'm taking this bit over here and I'm saying, what is inverse sine of that? And if I do that, I get 39.58, which you see on my calculator. Now, because I can visually see that this answer doesn't, the only other possibility is 180 minus that angle. And so this is the correct answer that fits this angle here. Okay, now that was a tricky one, and you did so well in the last lesson. I just wanted to start by showing you that it is possible to get two different answers for the sine rule sometimes. But the good news is it's only ever going to be 180 minus the angle. So Zoom users asked, how would you know if there are two possible answers? The way you would know is if you visually look at it. If the angle is obtuse, if it's bigger than 90, and you've got an angle that's less than 90, then you just go 180 minus your small angle, which would be this one here. And this situation is called the ambiguous case. And it's ambiguous because there's two possible answers. But once you know about it, it's not hard to use. You just need to be aware of it. Okay. And then a question from Keisha. Keisha, what's your question? Hey.
Oh, I forgot to lower the hand down. Sorry.
No
You already
problem.
answered the question.
Fantastic. Love the questions, guys and girls. Now, for those students who are still feeling unsure about the sine rule, I really want to recommend going back to my video lesson that we did in the previous lesson. You'll notice that we did a whole bunch of questions around sine rule. And that's why students are comfortable. So I really recommend you going back. But the main goal for today is to focus on something called the area rule. And so I'm going to start on that now. So question number one for today, in terms of the area rule, I want you to find me the area of this triangle over here. And you have to choose either option A, B, C, or D. Go ahead and give it your best shot. And if you're unsure about how to find the area of a triangle, maybe somebody can help us by putting something in the chat. What do we do to find the area of a triangle normally? has anybody ever seen the formula a half base times the perpendicular height? So a half base times perpendicular height. Now, if we look at this triangle, there's a right angle here. And I think that I could think of this as the base, and I could think of this as the height. Now, if that was the case, can you work out the area for me? I'll give you another hint. Imagine this is 2 units and that is 3 units, because I'm counting 1, 2, 3. So the area should be a half. And let's say if the base is 2 and then the height is 3, what's that going to be for my area? I think it's going to be 3 units squared, which is A. So in grade 9, you would have learned, or maybe you didn't because COVID was happening, and that's why, it's important to learn these things now. A triangle's area normally is a half base times the perpendicular height. But what's important to have a height is you need a right angle like this. Give me a thumbs up if the area formula for a triangle looks familiar to you. Thumbs down if you feel like you've never seen the area formula for a triangle. Okay. So using that idea, I want you to have a look at this thing over here. The question says the following. It says, find the area of this triangle. And all they give you is a side of length 5, a side of length 6, and the angle in between. Why is finding the area of this triangle harder than finding the area of the previous one? Who would like to share their thinking about what makes this harder? Morgan, you are on the money. There is no 90-degree angle. You don't know. In fact, this cannot be the base and the height. And so you don't actually have the height of the triangle. The height of the triangle would have to be something like, something like that. Or if you measure it from here, it might be like a right angle to there. But you don't have information. But do not worry. I will teach you a new tool today called the area rule. And all you need to do to find the area of a triangle is you need 2 sides and the angle in between those 2 sides. Now, again, you're going to have to take this on faith for now because I'm not going to have time to show you the proof today, but this is how the area rule works. You go a half times the length of one side times the length of the other side times the sine of the angle in between those 2 sides. So I want you to try, if you think about the fact that this is one side, this is another side, and this is the angle in between them, using this formula, what I'm going to call the area rule, what is the area of this non-right angled triangle? And I want you to pop that in the chat. So pop it in the chat if you feel like you've got something. I know that I'm going to put a 6 here, a 5 here, and a sine of 78 over here. So maybe on my calculator, I can go 0.5 times 6 times 5, the sine of 78. And what are you getting? 14 So in this case, we would get 14.67 units squared. So to use the area rule, all you need to do is go a half. You need the half in front, then the length of one side times the length of the other side times the sine of the angle in between. Give me a thumbs up if it makes, if you sort of understand what process to follow. You don't have to understand it perfectly, but if the basic idea makes sense, give me a thumbs up. Like you know how to follow the rule. And then test it out. Okay. Then let's do this one. Now, actually, you know what? Let's do this one over here before we get to that one there. So I'm going to blow this one up so that you can have a go at it. Find me the area of this triangle using the area rule that I've just explained to you for the first time. Notice that this tool will work for, there's no 90-degree angle in sight. You've just got two sides and the included angle. So I've got the one side. I've got the other side, and I've luckily got the angle in between. So, and then that's going to be the sine of 60. So you put it in your calculator, you go 6. Oh, no, I've forgotten the half. The half, 0.5 times 6 times 7 times the sine of the angle in between. And if you get this funny looking thing, I hit the SD button, and then you should get 18.19, and this will be centimeters squared. Okay, so this is such a cool tool because you don't have to worry about finding the base of the triangle. Well, you have the base here, but you don't have the height. But that doesn't matter as long as you've got another side and the angle in between. Then the area rule will work. Zoom users ask, do you always use sine? Yes, the area rule, and I'll talk about the area rule, always has a sine in it. And it always has a half in front, then it has one side, then it has another side, and those sides need to be next to each other, and then you have the sine of the angle between the sides. Okay, let's do one more before the break. Find me the area of this triangle. Find me the area of this triangle. So ask yourself, where does each, do we have two sides? Do we have the angle in between those sides? And how would we use them? So what I get is 39.27 centimeters squared. Okay, so we're going to take a little break now because we're human and we need to take care of our bodies. Tando was asked, does it need to be written as centimeters, or will it be wrong if you write units squared? So generally, Tando, I don't think we would penalize you, but it's good practice to use the units that they give you in the question. So, if they give you centimeters, then have centimeters squared. But it depends on the teacher. I shouldn't really. You're normally limited to 1 mark for rounding. Okay, so what have we done in this first part of the lesson today? We covered something called the ambiguous case, which is something that happens when we use the sine rule. And we just have to watch out that there's 2 possible answers. And so if visually we see it looks wrong, we just need to know how to tweak it a little bit. Then in the second half of the first half, we got introduced to this area rule. And the area rule allows us to find the area of any triangle. We don't need to have a right angle. All we need is 2 sides and the angle between those 2. Okay, but time for a break. So what I want to do is I want to stop sharing and I want everybody to stand up with me, turn on your cameras, and I want you to get up and I want you to move your body a little bit and start by just loosening up your arms, give them a little shake, shake this arm, shake that arm, shake your legs, give them a shake. Okay, so we're just trying to loosen up our bodies so that we kind of get all the stiffness out. Then I want you to take your tricep, stretch that, and look off into the distance. Oh, goodness. So stretch that. And then look off into the distance to rest your eyes. And then turn somewhere else. Stretch your tricep, look off into the distance. And the reason we do this is just to rest our eyes. Okay, then let us roll our shoulders. So we're just going to roll our shoulders back and roll our shoulders forward. Then let's stretch out like this. And then switch to the other arm. And then let's shake it out again. So shake your arms. Shake your legs. And then just take 3 nice deep breaths. One more. Okay, so hopefully you're feeling a little bit less stiff and a little bit more relaxed. We're going to do some jumping jacks just to get our heart rates up. We're going to do 15. Okay, and we'll do 15 jumping jacks in 3, 2, 1. Let's go. 2, 3, 6, 7, 8, 9, 12, 14, 15. There we go. Okay, tell me how you're feeling in the chat. Do you feel like your brain has had a break and that you have forgotten about what you were doing before, or do you feel like it made no difference at all? Let me know in the chat. And while you're doing that, see if you can, in fact, I'll give it a go. See if you can solve today's puzzle. And you need to tell me, what do all of these things equal? So we have millies and pizzas and sandwiches. See if you can figure out what 5 or 6 sandwiches plus 3 millies plus 2 pizzas are equal to. I know in class, sometimes when I make my classes do exercise, they roll their eyes at me, but I know it's good for them. So I give them a bit of tough love. I really do believe in exercise between maths. We're not made to sit as much as we're made to in the modern world. Okay. What do 2 millies give you? What do 2 millies have to be equal to? So I think all of these must be 12, 12, 12, because that gives you 36. But there's 3 millies here. So actually, how much is each one worth? Each milli is worth 6. So this would have to be 18, and that would have to be 18. Okay, so I've helped you with the first bit. Now we need to ask ourselves, how much is a pizza worth? And then can we bring it all together? Is pizza really 45.5? Because we need something. Because it's 12 times something, and then plus that something. So Annie has suggested that the pizza is 7. And I think you're right, because 12 times 7 is 84, and 84 plus 7. Now, that means each of these pizzas is 7, so that needs to be a 14, and that needs to be a 14. So the last thing, this is a bit of a tough one today. We don't normally do something this tough. We might need the calculator to help us. So what are we going to get for one sandwich here? I might even have to use the calculator. So 1 times 18, so 7 has been suggested. So 7 times 18 is 126 plus 14. That doesn't quite work. We're getting close though. 8, so 8 times 18 plus 14 gives me 158. So it's 8. So then it must be 2 each. Eh? That's 2, that's 2, that's 2, that's 2, which means here, if each of those two are, that's going to be 12. Sure, this is the toughest one we've ever done. So what's the final answer going to be? It's going to be 18 times 14 because of BODMAS, and then we add 12. And what is the final answer? Drum roll, please. It is 264. Nice, Bitsia and Ilichle and Sean. Very nicely done. And to all our other students, I see you smashed that. So well done. Okay, that was quite tough. For our newbies, we don't normally always do a puzzle that's that hard, but you know, it's nice to keep it fresh and interesting. Nicely done, Lalama. Okay, let's go back to our lesson. So what were we learning about? We were learning about the area rule, and I want to apply the area rule to a few more questions, just so it really gets stuck in my brain. So here's your choice. Which of the 4 options do you think gives you the area of this triangle? Choose A, B, C, or D. I'll let you work by yourself a little bit there. Ask yourself, what is the structure I need to help me? And indeed, you should be getting 149.1 centimeters squared, which is A. Now, before I move on from this, I want to ask, are there any questions or comments? One of the lovely things about Watobe is we really have this interactivity. And so if you have a question or you're feeling unsure, there's 2 easy ways you can ask a question. One is put your hand up. The other way is to put your question in the chat and I can read it. But I just want to make sure that somebody who has a question has the opportunity to ask if they're thinking it at the moment. Okay. Then let's do another one with a slightly harder feel. So can you find me the area of this triangle using the information on the screen? Yes, Lolama, what would you like to ask? You can put your hand up while students are doing this and we can chat audibly, or you can use the chat. Up to you, whatever's quicker. When do we use the sine rule and the cosine rule? So Lalama, we're going to talk about the cos rule on Wednesday. And so at the moment, what we're doing is we're just making sure we know how to use the rules. And then once we know how to use them, I'll talk about how do we select which ones. So that's almost like we first need to know all the tools in the toolkit before we decide which tool we use. Okay, so the main part of this question was to realize that the relevant information are these two pieces and this angle. This angle at the top here is irrelevant. And so what you should have done is you should have said the area is a half times 12 times 9 times the sine of 75. And you should then get, let me just check the calculator. I know you can't see it right now, but I've still got it here next to me, times 12 times 9 times sine 75. And you should get 52.2 or A. I just want to do a quick little vote. Thumbs up if you're feeling confident, thumbs down if you're feeling a bit left behind. Just want to have a quick little class vote because I can't see everyone's faces right now. I can see some faces, but it's helpful for me as a teacher to know kind of how the mood is in the room. So a good question, how would you know which angle to use? So the way you would know which angle to use for the area rule is you would look at, if you're given two sides, you're always going to look for the angle in between the two sides that you know. So that's the key thing. Whenever you use the area rule, think of two sides and the included angle. That's what you're looking for. Okay, let's do a slightly different one now. Which of the following work out the area of this triangle? And you're given a little bit of false information, you're given a little bit of distracting information, and your job is to see which one is correct. So Lama, we're going to do 2 and 3 dimensions. We'll talk about 2 dimensions, mainly in grade 11. 3 dimensions is for grade 12. Okay, so if we look at, we know that we don't have this angle, which is a problem, but we do know something about triangles and that they always add up to 180. So I think the blue dot is just going to be 180 minus 72 minus 24. And what does that give me for that angle? 180 minus 72 minus 24, and we should get 84. And once we've got that 84 there, that makes life a bit easier because we should be looking for a half times 26 times 14 times sine 84, which is D over there. So that was trickier, huh? That was a bit tougher. And the reason it was tougher is you had to do some steps before you got there. But if I look at the chat, I definitely saw D. You guys figured that out automatically. So well done. And if you didn't, just, now you know. Okay, you've done so well today. I want to take it up to a level where instead of numbers, we use letters. Okay, so what you're given here is with triangles, the little sides or the little, the lowercase letters are given as sides and the angles are given as the uppercase letters. Which of these four options will find the area of this triangle? And I want you to think about which one fits the rule that you've been learning about today. So what am I looking for? Well, I see a cos, so that can't be correct. It can't be causes. So now what am I looking for? Well, I'm looking for the length of two sides and the angle in between. So half A times B times the sine of C. That looks good to me. What about this one? A half A times B times the sine of A. No, that doesn't work because I need the angle between the two sides. And so the correct answer should be that one, because I really needed, there's the one side, there's the other side, and then I need the angle in between those, which is the sine of C. So when we write the area rule, you often see it written like this. You'll see it like in some textbooks, they go a half A times B times the sine of C. But you also sometimes see it written a half A times C times the sine of B. And sometimes students find that a little bit confusing. There's one other way we could have written this. What do you think that's going to be? There's always going to be a half. But what we could have written it as, we could have written it instead of A and C, we could have written not A and B. What's the one that's left out? What are the two sides that we haven't? We could have said a half B times C, but what's going to be the angle that we need then? I think it's just going to be the big A. Yeah. So the good news is this rule works no matter which way we have it, as long as we've got two sides and an included angle. So how do we know which one we're supposed to use? You just use the one that's easiest. I just wanted to, at the end of this lesson, start to describe, I wanted to make sure you understood what that meant and that you could also write it in this way, or you could have written it in that way. But in this question, the only option that was correct was this one. And so that's why you went with that one. Okay. Okay, last question for today. You guys have done so well that I'm actually getting into the next level type of question. This is the last one because this is a bit tricky. We're going to do this one together. Okay. First of all, I want to know what is different about this question compared to all the other ones? No angles are given. Yes, Morgan, there's no angles. And this question says to me, even though it gives me an area, it tells me what the area is, they want me to find the angle over here. Who has an idea about how we might be able to do that? Anybody got a, like, if you think about logically, how could I kind of work backwards or like something like that, maybe? Who has some ideas? Use cos? Naomi, I don't think we're going to use cos because remember, we've given the area rule. It's not a bad guess, but we've got the area. And I need something that there's no right angles here. So I was thinking, what would we normally do? Wouldn't we normally say a half times something times the sine of something to find the area? And in this case, we know what the area is. We know it's 48. what other things do we know that we could fill into the brackets there? What other ones could we fill into the brackets there? Well, we've got the 11 and we've got the 14. So Naomi agrees. And I think I have this and I have this, but I'm still not done. What I need to do is I need to figure out, I'll put like a big X. I need to find what that is. So what I'm going to do is I'm going to take all this stuff and I'm going to move it to the other side. Now, how do I move it? I'm going to have to divide both sides and get, basically, I'm going to have that. Give me a thumbs up if you follow me do how I did that. So I had 48 on the side. I'm dividing by all of these guys. So all of this, it was times on this side, it became divide this side. Now the problem is I don't want the sine of x. I want this by itself. And how am I going to get that? I need to use inverse sine on my calculator. So take out your calculator and share the whole screen so you can see the calculator again. I'm going to go shift sine. So I'm going to go shift sine, and then I'm going to have 48 on the top, and then on the bottom, I'm going to have 0.5 times 11 times 14, close brackets. And if I do this, I should be getting an angle out, and I get 38.56. So x is 38.56. Is there an option that matches that? Well, if you round to one decimal place, it's going to be A. And that's it. So if we look at what we did today, the main thing we did today was we learned how to find the area of any triangle. And in order to do that, you need two sides and the included angle. You don't actually have to have a right angle as long as you've got this made. And then you can use this thing called the area rule. And that's it. So I hope that that was helpful to you.